Hi, and welcome to another tutorial video. In this tutorial video I'm going to be talking about binary left and right shifts. So let's take a look at binary left shifts first. So here we're performing something called a logical left shift. When we're performing a logical left shift, we add a 0 after the least significant bit of a binary number. So let's take a look at an example of this. So I'm going to be using 8 bits for my examples here, and I've got the example 8-bit pattern here, and it's equivalent to decimal 13. So if we add a 0 after the least significant bit of this binary number, we end up with this bit pattern, and we end up with a bit pattern which is equivalent to decimal 26. So just take a look at these two decimal numbers that we've got here and see if you notice any possible relationship between them. So what we can do then to our original decimal number 13 is if we multiply it by 2 to the 1, we get 26. This is an example case of the fact that performing a logical left shift on a bit pattern has the effect of multiplying it by 2 to the n, where n is the number of bits it was shifted. So when you're doing a logical left shift, you're essentially doing the calculation I've got at the bottom there. You're taking your original number that you've got in binary, you're multiplying it by 2 to the power n, where n is the number of bits that you're shifting it left by, and to get the new number. So let's take a look now at a logical right shift. So logical right shift has the effect of adding a 0 before the most significant bit of a binary number. So let's go through an example of this. So I've got the binary equivalent here of decimal 8. And if I perform a logical right shift of 1 bit on this bit pattern, I get the following bit pattern, which is equivalent to decimal 4. And you may notice again that there's a relationship between these numbers in that if we divide our original decimal 8 by 2 to the 1, we get decimal 4. And that's because doing a logical right shift has the following effect. So doing a logical right shift, you're essentially doing this calculation. You're taking your original number, dividing it by 2 to the n, where n is the number of bits you've shifted it by, to get the new number. Okay, so that's just a quick overview of how to perform a logical left shift and a logical right shift, and what the effect of doing so is. Thanks for watching.